the next topic is FET based phase shift oscillator. So here I shown the circuit diagram and phasor diagram. So this circuit diagram belongs to the feedback network where R and C are connected in series. This is a phasor diagram which is drawn based on this circuit diagram, where along x-axis current I is taken, along y-axis voltage Vc is drawn, and here another important point, it is drawn in the third quadrant. So I will explain why it is drawn in the third quadrant. First we will focus on what is phase shift oscillator. So this is FET based phase shift oscillator. Here it contains one FET with the resistors Rd and Rs just to operate the Q point in a saturation region where Cs is a bypass capacitor. Another important thing, this FET generates 180 degree phase shift. So according to Barkhasan criterion, a circuit should generate 360 degree or 0 degree phase shift to oscillate. So here there is a feedback network which contains 3 RC sections, and here each RC sections can capable of generating 60 degree phase shift. So total 60 degree phase shift into 3, that is 180 degree phase shift. So therefore we can say that the total phase shift generated by this circuit is 360 degree, which satisfies the Barkhasan criterion. Next, now I will move on to the circuit diagram which I shown earlier. So this is a circuit diagram. Here C and R connected in series. So here across the C, the reactance is called as XC, and across the R, the resistance is R. Now these two are in series, so therefore you can write here the total impedance of the circuit. Here the total impedance of the circuit is Z equals to R minus JXC, because they are in series. So here XC is nothing but 1 by 2 pi FC. So substituting that value in this expression, we can write R minus J into 1 divided by 2 pi F into C. So this is Z equals to R minus Jx is in rectangular form, and the magnitude of Z with an angle of minus pi in ohms is in polar form. So that's why minus pi, because of minus pi, the phasor diagram is drawn in the third quadrant. That's it. So now here the current I, or the RMS value of the input voltage, is applied say as Vi volts. Hence the current I is given by Vi by Z. Vi is the input, Z is the total input impedance. With an angle of 0 degree you can take, or you can eliminate that one. So the total current I is nothing but Vi by Vz, Vi by Z at an angle of plus pi, because it is shifted from denominator to the numerator. So the total magnitude of Z can also be written as square root of R square plus Xc square. And now the important point is phase angle or the phase shift pi. So this pi is taken from the phasor diagram. Now in the phasor diagram, if I write the tan pi, so tan pi is nothing but opposite by adjacent. So here opposite depends on the current I, adjacent depends on the voltage Vc. So at the current I, Xc is the reactance, at the voltage Vc, R is the resistance. So therefore tan pi can be written as Xc divided by R, which is shown here. So this is pi equals to tan inverse of Xc divided by R. Okay, means we just write down the pi value here. So next is, now we know the value of pi. So selecting the capacitor and resistor value, we can determine the phase shift, which is 60 degree here. So based on the C and R. Now we'll move on to the 3 RC sections here, which is connected like this, where input voltage applied to the feedback and output voltage, if I compare the input and output, there is a 180 degree phase shift, which is shown in the waveforms also. So that's why I written here 180 degree total phase shift. Okay, this same feedback network is connected in this complete circuit to generate the sustained oscillations. Now we know that for any FET, that voltage gain, that is A, is given by Gm into Rd dash. Minus is neglected because it is written in magnitude, where Rd is dash is nothing but this resistance, which we already know. And here, according to Barkhasan criteria, the total loop gain A beta should be greater than or equals to 1, which is written here. A beta is greater than or equals to 1. But the value of A is gm into RD dash, and beta for the feedback network is 1 by 29 actually. It is written here directly because there is no derivation. So now, to satisfy the Parkinson criterion, so you can just substitute A beta equals to 1 here. Here if I substitute A beta equals to 1, now the expression written as gm into RD dash is greater than 29. So this indicates that the gain of amplifier is 29, greater than 29, and beta is equals to 1 by 29. If the circuit satisfies these values, then the circuit can oscillate. And this is the final frequency of oscillation taken as an expression, in terms of expression. It is f naught equals to 1 divided by 2 pi RC into root 6. So this is the detailed explanation of RC phase shift oscillator. Okay, no derivation here, just written the formulas and explanation. Thank you.